Dear students, now we try to see the definition of rank of a matrix. This definition is based on the concept of submatrix and det. Let us go into the definition. Let matrix A be a non-zero matrix. Non-zero means matrix contain at least one non-zero element. If all the elements are zero, that matrix is called zero matrix. Now we are discussing about a non-zero matrix. The rank of A is defined as maximum of orders. Maximum of orders. This word is very important in the definition of rank. Maximum of orders of the non-singular square submatrices of A. The word non-singular means whose det is not equal to 0. Whose det is not equal to 0. Square submatrices. Square submatrices. Let us see with examples. Later we will discuss these two observations. I have taken a 3 by 3 matrix. 3 by 3 matrix. Not necessarily the square matrix. Not necessarily the square matrix. First of all, I shall find a submatrix of highest order in this 3 by 3 matrix. As I said, every square matrix is a submatrix of itself. Not only the square. Every matrix is submatrix of itself. How to find rank of a matrix? Very simple. Try to understand carefully. From this 3 by 3 matrix, I want to find maximum order submatrix. Maximum order submatrix by deleting 0 number of rows and 0 number of columns. Means matrix A is a submatrix of itself. Submatrix of itself. In the definition, what we need, see here, rank of A is defined as maximum order of non-singular square submatrix. So non-singular means find its det. Find its det. We know how to find det. According to that, I found the det. 1 into remove row and column 4 elements. For the middle element, change its symbol. So minus 2. Again remove row and column 4 elements left plus 1. In that procedure, I explained earlier how to find det. According to that procedure, det value is minus 5. This is non-singular matrix. Non-singular matrix. If det is non-zero, matrix is called non-singular. So this is non-singular matrix. Matrix A is a submatrix of itself, of highest square submatrix, whose det is not equal to 0, which is singular. Therefore, rank is highest order. What is the order of this matrix? 3 by 3. So, you have to take only the square submatrices. You have to take only the square submatrices. Since this is itself a square matrix, I want to take maximum order square submatrix whose det is not equal to 0. So rank is 3. So this is a square submatrix. What is the order? Order is 3. So rank of this matrix is 3. Now we shall move to one more example. Example by taking matrix B. What is the order of the matrix B 3 by 3? What is the possible highest order square submatrix? 3 by 3 is the highest submatrix. Find its det. Find its det. If you find its det, you will get det B. Because the matrix is named as B, det B is equal to 0. So, rank is not equal to 3. If det is 0, rank is not equal to 3. Because what is the order here? 3. It cannot be equal to 3. You need a matrix, a submatrix whose det is not equal to 0. Whose det is not equal to 0. So, take submatrix of order 2 by 2. 2 by 2. So, from this 3 by 3 square matrix, find a submatrix. Why you are finding submatrix? Because I got singular matrix. This is singular. I need non-singular. For that, take submatrix of order 2 by 2. Any one submatrix of order 2 by 2. Here, I have removed third row and third column. Third row, third column. -1, -2, 3, 4. Now find its det. AD minus BC, -4, minus into minus, plus 6 equal to 2, which is not equal to 0. If det is not equal to 0, it is non-singular. According to the definition of rank, this is the highest order square submatrix which is non-singular. Then the highest order is called rank. So rank is equal to 2. Rank of this matrix is equal to 2. Suppose if this submatrix det is also 0. suppose if this matrix det is also 0, now take one more submatrix of order 2 by 2, because there is many number of 2 by 2 square submatrices. You have to identify at least one submatrix whose det is not equal to 0 of order 2 by 2. If you are failed in finding det of 2 by 2 matrix is 0, now go for one more submatrix of order 2 by 2. Check whether its det is 0 or not. If it is 0, go for one more square submatrix of order 2 by 2 until you get det is not equal to 0. Then rank of matrix is 2. If all the 2 by 2 square submatrices are singular matrices, in such case det is 1. Means rank is 1. Rank of the matrix is 1. But in this particular example, I identified a square submatrix of order 2 by 2 whose det is not equal to 0. So rank is its order, whose det is not equal to 0. Right. Let us move to one more example. There is a matrix C with 3 rows and 4 columns. What is the highest square submatrix we can form from this matrix? With this we cannot write 4 by 4 matrix. 4 by 4 square submatrix. We can write highest order square submatrix is 3 by 3 by deleting this column. You can delete first column, the remaining is 3 by 3 matrix, or you can delete second column, the remaining 3 columns and 3 rows form 3 by 3 matrix. If you remove this column, remaining will form a 3 by 3 square matrix, square submatrix. So you can take any one square submatrix of order 3 by 3, which is the highest order. I am taking C1 submatrix. Square submatrix of C is C1. I have removed this column and I calculated its det. As a result, I got 1, which is non-singular. Therefore, rank is 3. Rank is 3. Suppose C1 det value is 0. Now go for one more square submatrix of order 3 by 3. Its det is 0. If you remove this column, what the matrix remained as a submatrix, its determinant is 0. So you need to find at least one submatrix of highest order whose det is not equal to 0. Then the rank is defined as maximum order of non-singular square submatrix. Right. Let us go for one more example. A equal to 1, 2, 3, 4. What is the rank of this matrix? We know that this is a square matrix. Highest square submatrix is 2 by 2. So A is submatrix of itself. So find det A. 1, 2, 3, 4. AD minus BC. 4 minus 6 minus 2 not equal to 0. Therefore, rank is 2. Because the order is 2. Suppose there is a matrix B 1, 2, 1, 2. We know that B is a submatrix of itself. Find det B. 2 minus 2 equal to 0. So rank is not equal to 2. Now go for its submatrix by removing row. See here, if you remove only one row, you are left with a rectangular matrix. To discuss about the rank, you need square submatrix. Square submatrix. So you have to remove one row and one column. If you remove only one row, you are left with one row and two columns. But we need square submatrix. So for remove row and column, you are left by one. Single element matrix whose det is itself. So rank is 1. Like this, we need to find rank. Once we go to the observations, rank of 0 matrix is defined as 0. Means if all the elements in the matrix are zeros, rank is defined as 0. Next, rank of A is denoted as rank A, or this is the symbol of rank. Rank